Right, everyone, this is starting to get back on track with the talks.
Right, are we ready? Hopefully you all had a good night's sleep and enjoyed the whiskey tasting. I certainly did. My talk is a little bit about looking at the comparing different protocols, and what I mean by that is basically looking at different camera angle settings, a little bit moving on from what you've been doing with looking at a 20-degree image. Now, there are various protocols, obviously depend on your camera, which camera angle you want to choose. I think the majority of us is using a concentric annulus around the optic nerve head by now, and the size of the ring segment around the optic nerve head still varies between sort of different machines or approaches. Now, the other thing is, what vessels do we want to select? Are we using all the vessels that course through the analysis annulus? Are we just using the major arcades that course through? Are we having any adjustable sort of annulus so that we can account for magnification if we, for example, have a highly myopic eye? So there are various approaches. Then the quadrantic approach to take just information from different quadrants. But each and all of them have their little problems. Now, I've looked at that because I thought a lot of people using a 50-degree image, other people using a 30-degree image, and when you analyze your results and you write them up and you want to compare, how can you compare them? Is it good to compare them? How much variation is in there? And the other thing is also, should I include all the vessels that run through that measurement annulus, or can I just use a few of them? And I think that's important to consider when you have sometimes the trouble if you have one vessel obscured from hemorrhage, or you've got it obscured for the whole time because there's some pathology going on, so even in the follow-up you can't measure that vessel. Could you sort of leave that out, or would that have a massive impact on your measurements? We wanted to see a couple of other things as well, which were, what's the influence of the number of vessels included? Does it really matter whether I have 6 arteries and 7 veins, or is it comparable to if I just take the major 4? And how comparable are the results in the measurement annulus at 30 and at 50 degrees, as well as looking at single vessel comparisons, 30 to 50 degrees. So there are a couple of publications out there which haven't looked at comparing protocols, but obviously on comparing test, retest, whether this is short term or within one session, and the majority overall have shown pretty good reproducibility or repeatability results. However, I think the question isn't just about doing those studies, but it's about how do we analyze the parameters that we get out of it. What do we want to know? Do we want to know the extent of the difference between the two? Do we want to know the extent of the difference, how it varies along sort of or across the different values that we can measure, so across the whole range of saturation values, for example? And depending on what's the question, we should carefully look at the statistics that we use, because there is the problematic with using just correlation coefficients, how much sort of value is in that. ICCs, how much value is in that? Do we calculate intraclass correlation coefficients for absolute agreement or not? Looking at standard deviations or other measures, it's quite difficult, but it usually doesn't give you a lot of information across the whole spectrum that you've measured, and doesn't give you much information how much are they really different. It was lovely yesterday, and I've just thought I have to throw that in. If we just think about the whiskey tasting, and if you just think about something like you give each of your 5 whiskeys sort of a rating of 1 to 10. If we then compare sort of different or test, retest Would it be good to just have a correlation or averaging or mixing, or would it not be better to do something like a blind Altman, for example, to figure out what is actually the bias, what's the sort of variability, and also looking at the whole range of saturation values that we measure. So we've looked at healthy individuals, we've measured their IOPs, BPs, and everything else as usual. But now for this analysis here, I just brought along what we've done with oximetry. So we basically have taken 5 images, each with a camera angle set at 30 and 50 degree. And we then used 3 images of each of those settings to calculate averaged single vessel and averaged annulus parameters. Previous slide. Just a single vessel analysis. It's very difficult because there is so much variation across the different vessels. Once you average across the whole annulus, you're already improving that. But there is absolutely no difference when you consider what's the variation from test, retest, whether you take all the vessels or if you just take the 4 largest. So I think that's quite nice because it could make things a little bit easier for analysis. Because I think the biggest problem is still we need to sort of more standardize things if we want this to be a clinical tool, easy to apply, easy to analyze, and also to create the software that is sort of easy analyzing or making it more accessible for the clinician, so that we get to a point that we sort of feed in the image and we can click a button and it pops out with the values, rather than having to do a lot of interaction with the software and with everything. So I think sometimes, rather than trying out a million new approaches, we need to look at what we do now is increasing in quality and reliability, but also that we can compare all our studies a little bit closer. We also did an analysis looking and plotting sort of the variables against the number of vessels included, and it basically didn't show any association. So it didn't matter if you have an eye where you included just 5 arteries or where you have 7 arteries, and I'm sure you've all seen the anatomy is so different from patient to patient, and you will sometimes not, even if there are loads of vessels, not be able to analyze them if they're very close to each other, or depending on what pathology you have, if you have something above the vessel or obscuring the view, that you cannot analyze all the vessels. I also think we should have a look at those blind Altman plots a little bit further, in order to not just compare the methods and look at the quality of our test, retest, reliability, but I think they could be useful for looking at patient evaluation and differences between the groups too. And what I mean by that is, for example, well, I've just added a few little extras in here, as you can see with the red triangles. I think if you'd have a very large normative database, for example, and you've observed patients over a longer time, you have the information about age and how things sort of progress through age, but also through pathology. You could then sort of utilize that collective knowledge of such a large group, and if you have your patient, as here sort of represented by the red triangles, you could plot them sort of from visit to visit, and maybe a couple of the first visits they would sort of hover around within the limits, where you could get at least some information there, sort of okay in a safe area, whereas maybe with time, if you keep plotting it, you can see how they slowly sort of move outside this zone, and that could sort of represent a measure of progression, but also give us a little bit of a timeline, how things get worse over time or how things improve over time. And that's it already. So any suggestions? questions?